Hello everyone, welcome to a 2-hour course on the basics of corrosion for the oil and gas industry. The first section is electrochemistry of corrosion. Corrosion is defined as the environmental degradation of metals and alloys. This environmental degradation can occur in parts as small as the nails and as large as the gears as well as the pipes. This degradation can occur during the storage conditions as well as during the operation. In each of these cases, the corrosion leads to material loss which will affect the integrity as well as lead to additional cost to buy better and newer materials. Corrosion is basically based on Gibbs free energy. So Gibbs free energy is the energy present in a particular metal which determines how active the atoms of that metal or alloy are to interact with its environment. Now we should assume it to be, suppose, this hill of energy. Now if the metal is present in the form of an ore, then it is in the most stable state and hence it will be at the lowest energy state. So let's assume it to be a ball. If we want to refine it into a pure metal and an alloy, we have to put in energy which will push this ball to the top of the energy hill. Obviously, as we can see here, the inflow of energy will lead to the ball or the alloy having a very high energy state and it is unstable. So it is just perched at the top of the hill. The moment it is able to interact with the environment, it will start corroding and it will start forming the stable oxides which will have the lowest energy state, which means that it will start moving down the hill and it will remain at the bottom of the hill in the corroded state. So when we want to prevent corrosion, we are basically trying to stop the ball rolling down, and this can be done in a couple of different ways. Now usually corrosion is counted in terms of mils per year, that is 1,000th of an inch, or millimeter per year material loss. It means that if you have this equipment, then it is going to lose 1,000th of an inch of material all over the surface in 1 year. If we count it in per year, it will lose 1 for example per year. So if we want to calculate this, we have to assume the weight that is lost, the density of that material, because the density will be different for steel or its alloys, the area of exposure, whether it is the entire area or only a small part of area, and the time for which it is exposed. So all these parameters will give us the quantity of millimeter per year. This is okay if the entire surface is undergoing corrosion, because the weight loss will be significant in terms of the entire weight of the component. However, if we have a component such as this, then the material loss is happening only in very localized conditions. So the quantity of material lost here will be very small if we compare it to the overall weight of the component. Hence the MMPY or the MPY quantity that we will get will be so small that we will feel that okay, the corrosion is not really that significant. However, here the corrosion does not spread along the surface, it spreads through the component. So there is a possibility of it cracking or going through the thickness, and especially in case of oil and gas industry, it can lead to leakage of oil, gas and petroleum, and is especially dangerous. Hence it is necessary to take into account such kind of localized corrosion phenomena as well. Because we cannot use the previous weight calculations, we have to then go for electrochemistry.